In order to begin analyzing realistic, complex causal graphs, we'll use this video to lay out the ideas of causal and non-causal paths within causal graphs. These ideas will help us understand how statistical associations can be viewed as a combination of desired causal associations and undesired non-causal associations. Recall that there are three building block structures in causal DAGs that combine to make the entirety of any causal graph: chains, forks, and colliders. Previously, we talked about the independence and dependence relations in these structures. The key insight to take away from that discussion is that all three structures are paths from a start node to an end node, x to z, that have the potential to carry association along them from start to end. The phrase carry association means that there's potential for association to flow along the arrows to create dependence, association, correlation between x and z. The chain naturally carries association from x to z in that x and z are marginally dependent, but conditioning on y blocks the flow of association, rendering x and z conditionally independent. Blocking is a formal term that is used in the causal inference community to mean make independent. In the case of the chain, conditioning on y blocks the path between x and z, and doing so makes x and z conditionally independent. The fork acts the same way as the chain. Association flows from x to z, but that flow is blocked when the middle node y is conditioned on. The collider, however, does not carry association from x to z. The collision node y naturally blocks the flow of association. However, when y is conditioned on, association is carried through. X and z become conditionally dependent. This is often described as y unblocking or opening the association flow. In causal graphs used in practice, paths are generally longer than these three node structures and can be classified into two groups: causal paths and non-causal paths. A causal path, like the one shown here, is a directed path that starts at the treatment node and ends at the outcome node. From now on, the treatment variable will be denoted as A for action, and the outcome variable will be denoted as y. A causal path can also be viewed as a sequence of chain structures. You can think of causal paths as showing mechanisms from treatment to outcome. Although the causal path shown here shows several intermediate or mediator variables, a causal path could very well only contain the treatment and outcome. Including mediator variables is useful for some types of investigations, which we'll look at later in the course when we discuss mediation analysis. In short, causal paths are of main interest to us because they're the things capturing the causation that we want to learn about. Within causal paths, correlation is causation. A non-causal path is any path from treatment to outcome that is not a causal path. Non-causal paths must necessarily be undirected paths. Two examples are shown here. The idea of a non-causal path is important because such undirected paths can still carry association from treatment to outcome. Within non-causal paths, correlation is not causation. In real data, associations arriving from causal paths are mixed together with associations from non-causal paths, and the challenge is to disentangle the two. For example, in this causal graph, the AMY path is the one causal path. This path creates the causal association between treatment and outcome that is of interest to us. This causal graph also has the non-causal path A, B, C, Y. It's more complex than the building block structures that we've looked at because it has both a chain, ABC, and a fork, BCY. The second non-causal path is AMVY. Just like the other non-causal path, it's more complex than the building block structures because it has both a collider, AMV, and a fork, MVY. All paths from treatment to outcome, both causal and non-causal, create associations between A and Y. What we will learn in the next video is how to analyze association flows in more complex paths like the non-causal paths that we have here.